All right, 7.5 homework questions, starting with number 1. Is it the scale or the scale factor that doesn't have any units? Aaron? No. Michael, is it the scale or scale factor that doesn't have any units? The scale factor. The scale factor doesn't have any units. And why did we say the scale factor doesn't have any units? Why don't we have to write them, Lexi?
Because they have matching things.
Yeah, they're the same. They match up. So when your scale has matching units, you can eliminate those units. You can eliminate the labels. So scales always have units. For example, a scale could be like the map of Michigan we looked at was 1 centimeter is 50 miles. Those units are different. So we have a scale. But if I were to convert to make sure they have the same units, I would have a scale factor, and then I can eliminate those units and scratch them out. So scale factors would look something more like this, where there's no units. Okay, and they usually write it as a ratio, as a fraction. All right, number 3. How would you find the scale factor of a drawing that shows the length of 4 inches when the actual object is 8 feet long? Maddox? B, yes. Convert one of the lengths into the same units as the other length and then form a scale and simplify. Let's go ahead and do that for this problem. I'm actually going to do it in a different order. I prefer to simplify at the beginning so you don't have to do it at the end. So when we're doing a scale, or we're writing our own scale, the drawing measurement or the model measurement has to come first, and the actual measurement you list second. So our drawing dimension, it says the length of the drawing is 4 inches, and the length of the actual object is 8 feet. Now, does that scale reduce? It does. What number goes into 4 that also would go into 8, Frank? 4. So Frank, what's our new reduced scale going to say? 1 inch is 2 feet. Yeah, the units have to be written though, because they're different, right? It's a scale still. This is still a scale. Now we are going to turn it to a scale factor. And so to go from a scale to scale factor, I'm going to take the original scale, well, the original reduced one, which is 1 inch is 2 feet. And we need to convert the units to be the same, because we said a scale factor doesn't have any units because they're the same. In order to do that, we're going to have to write 2 feet in inches so that we can get the units to be the same. How many inches are there in a foot? There are 12, yes. So we're going to multiply the bottom number and only the bottom number by 12. And Izzy, how many inches then are there in 2 feet?
24.
That's correct.
24.
Now, why do we not write the, or why do we not times the top number by 12? Natalie? Alexis, why do we not times the top number by 12? Correct. Yeah, we want them to both be inches, and the top number is already in inches. And what do we do once the units are the same? Scratch them out. Yeah, eliminate them, cancel them out. And so our scale factor for this problem, although we don't need to write it, we are going to have to do it on tomorrow's quiz. We'll have to find the scale factor. Would be 1/24. So excuse me, make sure for tomorrow's quiz that you know that there's 12 inches in a foot, because that's going to be really important. Once you know how many inches are in a foot, you can convert whatever the bottom number there, which is in feet, whatever that is, into inches, and then that becomes your scale factor. That means that for every 1 unit, because now the units aren't important because they're the same, for every 1 unit on the drawing, it's 24 units in real life, which means the actual object is 24 times bigger than the drawing or the model. Okay, so keep that in mind. That's going to be important later. All right, moving on to number 4. Number 4, I've got the, you have your digital ruler, which you may have already measured these on your own. So your measurements hopefully match up or similar to my measurements. But it says, what is the actual length of the flower garden, and it says that each centimeter of the flower garden is 5 feet. Well, the flower garden is the entire flower bed here. What's the length of the flower bed according to our ruler? Someone who hasn't already answered a question. Maybe on. What's the length according to our ruler? Yeah, I would say it's probably closer to 5.1 or 5.2 centimeters. They did round it to 5. And so what I would need to show for my work for number 4 then is I would say if I measure 5 centimeters and every centimeter is 5 feet, would I multiply or divide by 5? I would multiply. I measured 5 centimeters. Each centimeter is a 5 feet. And so that's going to give me how many feet for the actual length, maybe on 25 feet. So make sure you have work, even though your work was as simple as timesing by 5. I need to make sure that you times by 5 and didn't divide by 5. So make sure you and also have the right label. There's more than 125 up there. Make sure you have the actual length being 25 feet, not centimeters. 25 centimeters is not very long. There's about 25 of them on this ruler. It's not a very big flower bed. Number 5, it wants to know the actual dimensions of the rose bed, which is a particular part of the flower garden. The rose bed is in the shape of a square. According to our ruler, what's the length of the square? Aaliyah? We're going from here to here. And so that little mark right there would just be 2, exactly. So our rose bed is 2 centimeters. Again, if every centimeter is 5 feet, if 1 centimeter, this would be my proportion if I was writing a proportion for this. If 1 centimeter is 5 feet, then 2 centimeters is going to be how many feet? 10. Yeah, you're just timesing by 5 again. And so 10 feet. So 2 centimeters times 5 is 10 feet. Make sure you have all that work written down for number 5. We jump to number 8. Number 8 gives us the map of Michigan here. And so I've tried to line up as best I can the cities of Kalamazoo and Ann Arbor. You know what's in Ann Arbor? No? Well, they have a football team or a college football team that's going to be playing in the college football playoffs next week. Michigan University is in Ann Arbor. And if you're a fan of Michigan State University, well, they're in East Lansing. So that'd be just to the east side over here in Lansing, Michigan. So anyways, we're trying to find the distance between Kalamazoo and Ann Arbor. I would say, according to my ruler, your ruler might be different as you rotated it and you got a better answer. Mine says about 2.1, but they rounded it to 2 centimeters. So if the distance on the map is 2 centimeters and each centimeter, like we did in our notes yesterday, is 50 miles, what would that be, Maddox?
100.
Okay. Just your line. Okay. So 2 centimeters, if 1 centimeter is 50 miles, then 2 centimeters would be, say it again, Maddox, 100 miles. And if I set up a proportion, it looks something like this: 1 centimeter, 50 miles, 2 centimeters, X miles. And I'm going to cross multiply. Of course, 1 times X is X, and there's the 2 times 50 that Maddox just did. So ultimately, we are just timesing by 50 here. So if you just want to write 2 times 50, that's fine. Okay, number 9, the distance between Lansing and Flint. Thank you. Lansing and Flint seem to be how far away using our ruler? Gage? 1 centimeter. So Gage, if 1 centimeter is 50 miles, then 1 centimeter would be 50 miles. Yeah, so literally 1 centimeter times 50 equals 50 miles. Number 10. Moving right along here. Grand Rapids and Escanaba. Now, Escanaba is up there in the Upper Peninsula, and obviously I wouldn't be able to drive straight to that city, but we're gonna find this distance as the crow flies, which is a straight shot, even though you can't drive that distance. You have to go through the bridge up here. And so that looks to be exactly how many centimeters? Whitney? 4 centimeters. So Whitney, if each centimeter is 50 miles, what's 4 centimeters going to be? If each centimeter is 50 miles, how long would 4 centimeters be? 200 miles, you got it. Don't forget to label. Labels are important in this section because it'd be easy for someone to put 200 centimeters and that would be definitely wrong. So 200 miles is the actual distance. Are you writing this down? Yeah, because you are turning in a work paper for this tomorrow. Unlike the homework for today, which we did in the notes, you are writing your own work paper for the 7.5. Yes. No, because I've already got work papers up here, so hang on to it for one more day. Number 11, the distance between Saginaw and Alpena. How far, what would you say that distance is, Maddox? On the ruler? 2.3. Okay. So 2.3 centimeters. Of course, each centimeter is 50 miles. What's 2.3 times 50, Maddox? 100, no. 115. Huh? Does that work?
No.
It doesn't work. Okay. So it's obviously not 2.3, even though I think my ruler says 2.3. That's why we're looking at these together. What do you want to try next, Gage? Just two? Okay. So 2 centimeters, maybe they rounded it to 2 centimeters times 50. Gage, what's 2 times 50? 100 miles. Does that work? No? Okay. What else can we try?
2.2.
2.2? Okay, let's try 2.2. Times 50 is 110?
Yeah.
Does 110 miles works for everybody? Okay, so again, it's just trying to figure out what exact measurement they got on their ruler. Of course, we're gonna get, maybe you rounded differently than they did, but they used 2.2. I think based on my ruler, it should actually be 2.3, but what do I know? I'm just a math teacher.
Right.
All right, number 12 gives us a scale factor. It says the scale factor is 1 to 12. Well, remember, scale factors don't have units because the units are the same. So when I use the scale factor, notice up here that it gives you the model length of the mattress and then the actual length of the mattress. The units stay the same because scale factors have the same units, which is why it's not listed. So can you tell me how many times bigger the actual mattress is from the model mattress? Alex? No. Michael, how many times bigger is it? Nope. Alexi? Nope. How many times bigger is the actual mattress? Gage? 12 times bigger. Remember, we just went over that with the last scale factor we did. This is the drawing. This is the actual. And so if it's 1 to 12, that means the actual object, in this case, a mattress, is 12 times bigger. So to find what that new length is, what the actual length is, take the model length and times by 12. And that's going to be what? 75 inches. So you need to write that you did 6.25 times 12. What if they would have given you the actual length of the mattress and asked you to find the model length? Would you times by 12? You'd have to divide because you got to go this way instead of going the other way. So you'd have to divide it back to see what it was. Number 17. Number 17 says a scale of 1 centimeter is 20 meters, which describes the error in finding the actual distance that corresponds to 5 centimeters. So if 1 centimeter is 20 meters, we should be able to set up a proportion to find how many meters 5 centimeters would be. Can you tell me why their answer or their work is wrong? Calvin, do you see?
I think they cross multiplied correctly.
They did, actually. 20 times x. 1 times 5. 5 divided by 20 is 0.25. They did cross multiply correctly. Hunter, what do you see?
They like.
How so?
They kept it. Like they flipped the centimeter.
Okay, so let's not say keep change flip. That might confuse a lot of people because we're not dividing fractions here. But you did say that they flipped the second fraction. How could you tell that they flipped the second fraction? Why should it not be that way? The labels are out of order, aren't they? So they wrote the correct scale. 1 centimeter is 20 meters. And then when they went to write their next ratio, shouldn't centimeters go on top? Yeah. They should have written it as 1 centimeter is 20 meters. So 5 centimeters would be how many meters? So which of these 4 options describes what the mistake was, Gage? B. Yeah, the 5 centimeters should have been on top, should have been the numerator. All right, we also have to correct the mistake. So if this is the correct proportion, after Hunter's told us that they flipped it accidentally, which by the way, when you write a proportion, you should label the proportion so you don't make dumb mistakes like this. If you label your proportion, you would know, oh, I need to put centimeters on top again. So when you cross multiply, what answer are we going to get? 100. 1 times x is just x. 20 times 5 is 100. And what 100 is what label? 100 meters. And that's another reason why you should label your proportion, because I can tell you right there, the x has an m next to it. Now m stands for meters. Joe, can you shut that door for me, please? Thank you. All right, number 18, use the provided ruler to measure the segment shown. Find the scale of the drawing. So when you measure the segment right there, how many centimeters is that segment, Frank? 4. Excellent. So it's 4 centimeters. Now we have to write a scale for this. So for the scale, we would say that, by the way, which of those measurements is the drawing measurement? Would you say the drawing of the boat is 4 centimeters or that the drawing of the boat is 120 meters? The drawing's 4. Okay, so 4 has got to be listed first. And which of those measurements is the actual length of the boat? The 120 meters would definitely be much longer. So that's the actual length. Remember the drawing number, model number, and then the actual number comes second. So drawing or model number, and then the actual number. Now that's a scale. Is that scale reduced? It is not. We should reduce it because nobody wants to use a scale that's not reduced because it has larger numbers than necessary. Can you think of a number that goes into 4 that also goes into 120? Maybe on 30 doesn't go into 4. Natalie, what number goes into 4 that also goes into 120? 4. So we're going to divide or reduce by 4. 4 goes into 4 one time. And Navion, how many times would 4 go into 120? 30 times. So the scale that we should write in as our final answer is a much reduced version of the scale. 1 centimeter is 30 meters. Now, how many, if I wanted to, I don't have to here, but I want to practice turning this into a scale factor, just so we're good on the quiz tomorrow. If I turn this into a scale factor, I would have to write it as a fraction and then get the units to line up. In order to get the units to line up, you'd have to tell me how many centimeters there are in a meter.
It's not 120.
It's 1 centimeter is 30 meters. That's the answer. How many centimeters are there in a meter? Aaliyah? Michael? There's 10 millimeters in a centimeter. We said that yesterday. Whitney? How many? 100. The prefix cent means 100, right? Just like a cent is 1/100th of a dollar, a centimeter is 1/100th of a full meter. That prefix cent, like century, means 100, right? So there are 100 centimeters in a full-size meter. So knowing that, I would times the bottom number by 100, so I could get that bottom number to be in centimeters. Someone please tell me what 30 times 100 is. Frank? 3,000. Again, this is finding a scale factor. It's not part of the problem, but something you'll have to do on your quiz tomorrow. So now that the units are the same, what do I do with the units? Everyone should be able to answer this. Cross them out. So how many times bigger is the actual ship from this drawing? 3,000 times bigger. Yeah, it's a lot bigger. Number 19, use the provided ruler to measure the segment shown. How long is that segment, Calvin? It is 2.4 centimeters. Which means our scale would be 2.4 centimeters is equivalent to the actual length of the eyeball, which is 24 millimeters. That scale is not reduced because it has a decimal in it. So we should get rid of the decimal. If I times by 10, that will get rid of the decimal. Do you know why? What happens when you times a number by 10? Oh, that's such a bad answer. You put a 0. Maybe sometimes. You're telling me if I did 0.873 times 10 that I should just put a 0 after the 3 and call it 0.8730? What does timesing by 10 actually do? Natalie, do you remember? Gage? It moves the decimal one spot to the right, which means that sometimes we do add a 0 if the decimal is already at the end of the number. In this case, it's not at the end of the number, so timesing by 10, oops, we'll slide it over and make it 24. This time the decimal is at the end of the number, so it'll slide it over and you'll add a 0 to make it 240. So now we have the scale of 24 centimeters is 240 millimeters. Now we can reduce it. What number goes into 24 that's going to go into 240? Go ahead. Yeah, 24 will go into both those. 24 will go into itself one time, and 24 will go into 240 10 times. There's your answer. What's interesting about this scale is that this eyeball you're looking at has not been enlarged or reduced at all. That's to scale. Not only does our scale say that 1 centimeter is 10 millimeters, but that's true in real life. In real life, there are 10 millimeters for every centimeter, which means they didn't enlarge or reduce this at all. It's exact same scale as it should be in real life. Okay, number 25. It says use the provided ruler. Suppose you recreate the drawing so that it has a scale of 1 centimeter is 4 meters. This is going to be our new scale. It says, what will the new length and the new width be? Well, what's our old scale? Our old scale is 1 to 8. So here's my question to you. If I go from a scale of 1 to 8 to 1 to 4, am I going to be getting larger or smaller? Ooh, we seem to be split on this. That's an 8th. That's a 4th. Think about a pizza that you order from Pizza Hut. Large pizzas come sliced 8 ways. If they were to slice it in 4ths, would the pieces be bigger or smaller? They may be a lot bigger. It'd be like crazy big, right? Oh, I got 1/4 of the pizza right here. So it's not only bigger, but how many of these 8s can fit inside of a 4th? 2. So not only are they making it bigger, but to go from 1/8 to 1/4, they're making it twice as big. Do you agree? Okay, so when I measured the length, I got it to be 5. So if the new drawing is going to be twice as big, what's the new length going to be? My goodness,
Oh.
you guys aren't looking very good today. If the old length is 5 and the new length is going to be twice as long, what's it going to be? 10. So we'll say 5 centimeters times 2, because it's going to be twice as big. I'll circle it real big for you. Then that means the new length is going to be 10 centimeters. Now, I don't have the measurement of the width. Will someone tell me what the measurement of the width of the old width is if you rotate your ruler? Yes. No.
I mean, what?
What is it, Andrea? It's 2.5. So when you measure it on the ruler, you're going to get 2.5 centimeters. Thank you for doing that. And so if the old width was 2.5 centimeters, the new width, which is twice as big, is going to be how many centimeters? 5 centimeters. So we have to, I didn't measure the width. You had to measure it yourself there. I don't have a picture of that one. Number 26. 1 centimeter is 4 meters. That's the new scale again. It's the same scale we just used, but the old scale this time has changed. So it went from 1/2 to 1/4. Does that mean it's getting bigger or smaller? It's getting smaller. 1/2 is much bigger than 1/4. So it's going to reduce the size. How many times smaller? If you went from 1/2 to 1/4, that looks like it's getting half the size. Yeah, it's getting reduced by half. So yeah, you would say it's twice as small, or you would just say it's half as large. So if I measure the length, so to go from 1/2 to 1/4, you're dividing by 2 in this case. If I measure the current length of 4, if I do my new scale, which is going to shrink it down by 2, what's the new length going to be? What's the new length going to be? The current length is 4 centimeters. The new scale is going to reduce that in half. Thank you. I don't know what world you guys are living in today, but I got a lot of people staring at their iPad, and I don't know what you're staring at, but it's not what I'm staring at. Okay, rotate that. What's the current old measurement of the width? What's the old measurement of the width?
1 centimeter. Right there.
Not an old scale. I want to know what this measures right here. Not 2.5. That was the last problem.
2.1.
It's actually, you're right. It's 2.1. We'll just say it's 2. I believe they use 2 instead of 2.1. So if the current length is 2, when I do my new drawing, which is half as big, what's the new width going to be? 1. Half of 2 is 1 centimeter. Number 30. In a blueprint, each square has a side length of 1/4 of an inch. Okay, so each square, like this one here, is 1/4 of an inch. Our scale says that each inch is how many feet? 16 feet. So if this is 1/4, that means that's 2/4, that's 3/4, and that's 4/4 or 1 full inch. So that 1 full inch right here is equal to 16 feet is what they're telling us based off the key. So if that's 16 feet, what's 1 square going to be? If 4 squares is 16 feet, what's 1 square going to be? 4 feet. 1 square is going to equal 4 feet. That's probably going to be more helpful for us than the scale they gave us. Every square that we see up here is going to be 4 feet in real life. It says ceramic tile costs $5 per square foot. How much would it cost to tile the bathroom? So to tile the bathroom, I would need to know the area of the bathroom. To find the area of the bathroom, I need the length and the width. So we'll start with the width. How many squares long is the width?
2.
Each square is 4. So that's a length of 8 feet. To find the length of the bathroom, now we're not going to tile the tub. That's 3 squares. Each square is 4 feet. So how long is that length? 12. To find the area of that rectangle, I should do length times width. Tell me what 8 feet times 12 feet is. 96 square feet. Nice job. So I need 96 square feet of tile. Each square foot is $5. I need 96 square feet. So what should I do? Times it by 5. 96 times 5 gives us $480. That is correct. It'll cost $480 to tile the bathroom. B, carpet costs $18 per square yard. Ooh, that's probably going to come in important later. How much would it cost to carpet the bathroom and the living room? So again, I need to know the area of the bathroom and the area of the living room. So, the bedroom. I said bathroom, the bedroom and living room. The bedroom is how many squares long? 5, and each square is 4 feet. So that's 20 feet. Thank you. How many squares wide? 4, and that's 4 times 4, 16 feet. So what's the area of the bedroom then? 20 times 16 is 320 square feet. That's correct. Now let's do the living room, because we're also going to carpet the living room. The living room is also 4 feet wide, or 4 squares wide, so 16 feet wide. How many squares long is the living room? 7. Each square is 4 feet, so that's a total of 28 feet. Oops, why am I changing that? So tell me what the area of the living room is then. 16 times 28 is 448 square feet. I'm going to carpet both rooms. So I'm going to go down here. The bedroom was 320 square feet. The living room, 448 square feet. That's a total of how many square feet? 768. That's right. So if each square yard costs $18, what should I do? Oh gosh, you're right, actually. Yeah. Did you notice that they switched to square yards? Yeah. So let me show you how we're going to do this, because the carpet's not sold in square feet. Otherwise, I have time to buy whatever that value is. We'll call this square a square yard. It's 1 yard by 1 yard. How many feet are in a yard? 3. So there's 3 feet by 3 feet. How many square feet in our yard then? What's the area of that square? 9. There are 9 square feet in every square yard. 9 square feet in every square yard. So if it's $18 for 1 square yard, how much would it cost then for 9 square feet, which is the same size as that square yard? What's 18 divided by 9? 2. It's actually $2 per square foot. I'm just finding a unit rate right there. So knowing that I need 768 of these, and each square foot's now going to cost me, because square yard doesn't help me a whole lot. Each square foot's going to cost me $2. What's that price going to be, Gage? What's that price going to be? You're not leaving until you're done, so you can not write it down if you want to. That would be your own fault. Why are you guessing? You have a calculator, Natalie? And 38. Okay, so that would be the cost. $1,538 to carpet, and that's going to be really expensive. 36. Okay, thank you for checking. So part C then wants you to compare their unit costs. We know that the tile was $5 per square foot. The carpet was $18 per square yard, but when we divided by 9, we found out that that was actually just $2 per square foot. So which one's cheaper? Really? Really, the tile's cheaper. The carpet's cheaper, which is why most houses have more carpet than they would tile, because it's cheaper. All right, I'll see you guys later.
But